Okay, so we'll continue with functions. So we were discussing the problem 1 by x, I guess, right? So is everybody clear with 1 by x? What are the different cases? What is the range you get if you take 1 by x? Yeah, I'll repeat. I'll take cases now again, and I'll try to explain. So for those who it's not clear, so let me take the function first. So 1 by x, right? So I'll give you the domain. You tell me what is the range. Okay. So if my domain is between 0 and 1, so what do you think the range is? 1 to infinity? Is it clear for everyone here?
Yes.
Why is it 1 to infinity? If you have a doubt, you can ask me, right? Your range is 1 to infinity. If you're not sure, just take some examples and see. So we start with, say, nearly 1. Okay, 1 by 1 is 1. So that's fine. Suppose I take 1 by 0.9, or if you want 0.99. What is this equal? 99. Yeah, it's 100 by 99, right?
Yeah.
Okay. If I multiply both numerator and denominator by 100, it's 100 by 99. Right? So this is little greater than 1. Fine. Suppose I take 1 by 0.9. What is this? 10 by 9 or 100 by 90 or 10 by 9. Still greater than 100 by 99, sure. If I take 1 by 0.8, 10 by 8, still greater. So you can continue like this, and you can go say 1 by 0.1. What is this? 10. Okay. 1 by 0.01, 100. And you come closer to 0. Right? As close to 0 you are, you'll be approaching infinity. Right? That is the logic. Okay. So therefore 1 by x, if I take this as my domain, this is my range. Is it fine? Clear? So again 1 by x, if it's from -1 to 0, I'm not including 0 anyway because it's not defined at 0, right? So I'm excluding 0. What happens if I take -1 to 0? -1 to minus infinity, or minus infinity to -1, right? Same logic again, same numbers you can take with a minus sign, that's all. So 1 by minus 0.99. So this is what? Minus 100 by 99, correct? Which is again minus 1 point something, less than -1. Fine. Next, you take the same example, minus 1 by 0.9. So it's minus 10 by 9. Next, you'll get minus 10 by 8. Now, if you take minus here, this is minus 10. Next example with a minus sign is minus 100, and so on. Now, you can see it's becoming closer to minus infinity. Okay, so that's the reason this is from minus infinity to -1. Fine. Suppose for the same, we have a number from -1 to 1, except 0. Not supposed to get phones here. Yeah, if it's from -1 to 1, minus infinity to -1, the union 1 to infinity. Right. You can see that simply I've just added these two ranges, right? Because that's what my domain is also. Simply adding these two domains. Can you see that? Okay. Now again for 1 by x, suppose my domain is from 1 to infinity. What would be my range? 0 to 1, right? So can I include 0? No. Okay, 0 when it's infinity, so I can't include 0. Again, the same logic from minus infinity to -1. So it is -1 to 0. Okay. Now, in general, if I say set of all real numbers, again, it's not defined at 0. What is the range? minus infinity to positive infinity. All the numbers? Sure. Okay, it's all the numbers minus 0 again. We discussed this, right? It can never be 0. So what do you mean by a set of all real numbers? It's a combination of this, I think this, and yeah, there are 4, right? This, you can just combine these. The union of all this set is nothing but r minus 0, correct? I've included each and every number except 0. Again, you see the union of all this set. This is nothing but your range. Now again, the range will contain all the numbers, all the real numbers, except 0. Is it okay? This is a little difficult, but you need to get used to 1 by x, right? Because most of your domain problems, at least, will have something in the denominator. Okay. So if they ask you something, a problem which contains something in the denominator to find the range, right? So usually the whole idea is figure out what happens to the denominator, what is the range of the denominator, then figure out what is 1 by that number, right? Suppose you get a problem where you know that the denominator is between 0 and 1, right? So you'll get your range. It doesn't matter if it's x or not, right? The logic is the same. Is it clear? So suppose your denominator in that example was cos x, right? For secant x. So what would be your answer? Let me just remove this and put secant x. Do not look back. Just think and tell me. Secant x, what would be a range? Yeah? Yeah, think. The same logic what we have done till now, you have to apply the same. What is secant x? Secant x is nothing but 1 by cos x, correct? Analyze. Minus 1 to 1. Okay. Same as what?
Same as minus into minus 1 union.
Okay. Okay. All real numbers. Okay. What about you? Or how many say all real numbers? Others are confused to raise your hand or not. What did he say? Okay, fine. No problem. Yes. All real numbers except minus 1 and 1. Okay. Okay. But minus 1 and 1 is possible, right? When cos x is 1, you will get 1. And cos x is minus 1, you will get minus 1. Any other answers? All real numbers except multiples of, that is you're talking about domain, right? We are talking about range now, right? Yeah, in domain we have to remove those points. That's correct. We are discussing range right now. Yeah. Minus 1 to 1 except 0. Okay, they're all different answers. So 1 by x is not clear then. Huh? It's clear. Then why are we getting different answers if 1 by x is clear? First, tell me what happens to this. What is this problem? Can you convert this problem into something which we can solve? Yeah. Yeah. What is cos x? Yeah. What is the range of cos x? Minus 1 to 1. Sure. Okay. So you are saying the denominator is minus 1 to 1. Is it fine? So what is the range of this? All real numbers. Yes, sure.
All real numbers except minus 1 to 1.
All real numbers except minus 1 to 1, right? Or it is this case, correct? It's not all real numbers. You get all real numbers only when your set of domain is all real numbers, correct? Now we have only numbers between minus 1 and 1. So your range is minus infinity to minus 1, union 1 to infinity. Isn't it? So when you have numbers in the denominator between 0 and 1, you're going to get 1 to infinity. If you have numbers between 0 and minus 1, you're going to get minus infinity to minus 1. If you have both the sides, you are going to get the interval, this interval. So it was clearly given here, right? Okay. This means what? See, x can take these values. Is it fine? X can take only numbers between -1 and 1. Here, if you see this problem, is taking different in your system which you have learned. It's degrees, correct? Degrees or radians, it doesn't matter. But the final output which I'm getting in the denominator is between -1 and 1. So isn't this equivalent to 1 by x with the domain -1 to 1? Again, I can remove 0, right? It is an equivalent problem, right? Is it clear now? Are you able to write the domain? Okay, okay, let me see. What about 1 by mod x? Let's talk about the domain and range. Domain will be except 0, all real numbers except 0. Please make a note of it every time, because we are used to leaving one number, which is very important, right? Except 0, yes. But what is positive real numbers? Sure. Okay. Positive real numbers. See, you people are comfortable when it's given as positive and negative, right? But when I give you the interval 0 to 1, you people are struggling. Okay. See, how do you get those positive numbers? It's again divided into two intervals. Like 0 to 1 will give you the numbers 1 to infinity. Is it fine? I shouldn't include 0. And your 1 to infinity is giving you 0 to 1. Okay. Is it clear now? So the combination of entire positive numbers is giving you the combination of entire positive numbers there. Is it fine? Okay, let's see. 1 divided by mod of sin x. 1 to infinity. What about the domain? We'll discuss the domain and go 0 to 1. Domain. Yes. No, 0 to 1 is not correct. All real numbers. No, again no.
All real
Except what?
even in
N pi. Yeah, n pi is correct. We have already discussed this, right? Denominator should not be 0. Sin x is 0 sometimes, correct? When is it 0? At 0, at pi, at 2 pi, so on. N pi. At n pi it's 0, right? So we'll just remove those values. So r minus n pi, where n belongs to integers. Fine. Okay. Range now 1 to infinity. See, if this is equivalent to a problem where we have sin x is a number between 0 and 1. It's actually a number between -1 and 1, but we have mod, which converts all the negative values into the positive part, right? So it's taking only the absolute values. Okay. So this is equivalent to 1 by 0 to 1, which is nothing but 1 to infinity. Is it okay? Yes. Okay. 1 by sine square x. Let's start with the domain. Same domain. Okay. R minus n pi. Okay. Range. Same. No change. Okay, fine. 1 by sine cube x. All reals. We're talking about range or domain now. Range. Let's finalize the domain, then we'll go ahead. -1 to 1. What is the domain? It's the same thing, right?
Yeah.
Why are you getting confused again? So it's r minus n pi, right? It's defined everywhere except when the denominator is 0. Right? Denominator is 0 when x is n pi. So So I'm removing those points. Now the range. Minus infinity to minus 1, 1 to infinity. Is it? Yes. See, now this is equivalent to 1 by a number between minus 1 and 1. Okay, why? Because see, sine cube x. Till now we saw mod of sine x, right, which is positive, sine square x, which is positive. But sine x and sine cube x takes negative values as well. Okay. So your answer is minus infinity to minus 1, union 1 to infinity. Fine. Okay. Let's continue. So 1 by x minus 2 into x minus 3. Before this, we'll just see a simple one. 1 by x minus 2 we'll see. Then we'll go there, right? 1 by x minus 2. All reals except 2. Okay. What about the range? What about the range? Huh? All real numbers except 0. Everybody agrees? Okay, fine, great. Now, shall I have x minus 2 into x minus 3? All reals except 2 and 3. Yes. The range is a little complicated. Have you studied quadratic equations? Yes. Yes. You have studied in 9th? Okay. Okay. Can you figure out the range? Let's try. Let's see. Can you figure out what the range is? First, try to figure out the range of only x minus 2 into x minus 3. If you can figure out, then we'll see 1 by that. 0 to infinity. How did you figure that out? We can't go to negative values. Okay. So one answer is range is 0 to infinity. It can be 0, right?
Yeah.
Okay. This is the answer for this, right? Negative infinity to positive infinity. How did you figure this out? You try the graph. Okay. Okay. Huh? All reals. How do you know it's all reals? Okay. You said you tried the graph. Yeah. What's the graph? Okay. So it's something like this. This is the graph. Yeah. Okay. So you have any idea where can this is x-axis? They cut. So this should be the x-axis. Is this fine? Okay. Fine. What about the y-axis? Should I keep it somewhere here? No. Where should it be? It won't be symmetric. Okay. No. Where should I keep the line? Here I should keep. Should I move it to the? Okay. Okay. Should I move it to the right, left? Anyway. Any specification? Or we don't know. Towards the left. Any justification for that? Yes, yes. Zeros are at 2 and 3, correct? This is the value of x. This is where it becomes 0. That we know. When I put x equal to 2, it's 0. 0 means what? An x-axis, if I put the value of x and I'm getting 0, means y value is 0. Right? Y value is 0 at x-axis. Okay. Fine. So this x is 0 is this side. If x is 0, then comes 1, then comes 2, and so on. This is not drawn according to scale, so you're not worried. You're just doing a rough sketch, right? Fine. So you're saying the range is minus infinity to infinity. From the graph, does it look like mine? What do you mean by range? In the graph, if I draw a function, what do you mean by range? A set of values of what? Yeah, of this graph, right? Of this graph, set of values. But how do you calculate? Like suppose I give you a graph. I won't tell you what the function is. Can you tell me what the range is? For example, if I give you this curve sin x, yeah? So you know the range already, correct? But even if you don't know, is it starting from 0? Right. Let's go to the other. Now we know this, right? We know these two lines. So how do you figure out what is the range? Maximum point and minimum point, right? Okay. Maximum point of what? Y axis. Because y, see, whatever you're drawing y equal to sin x, right? Or f of x equal to sin x. So y is the maximum value of y for in the graph, this point and this point. Is it fine? So if I know those 2 points, whichever is maximum, they're not looking like straight lines. So, but usually they're straight, right? So that will give you the maximum and minimum point. In this case, it is -1 to 1. Okay. So what about this graph now? What about this graph? Do you think it's going from -infinity to infinity? No. No, right? Yeah, it's going from minus some value. I don't know what the value is. Suppose I mention this as a, some minus a to infinity. This you people can agree, correct? So range is somewhere, I don't know this value, from minus a to infinity. Is this part clear? What it is? Now how to find that a? Any minus b by 2a. How do you know that?
Vertex.
Yeah. Is vertex minus b by 2a? Yeah, why is that?
Minus delta by 4a.
Yeah. Okay, I don't know why is that. So anybody can explain. So they're saying that this vertex is minus b by 2a. Then
Minus delta by 4a.
minus delta by 4a. Delta is b square minus 4ac if I'm not wrong, right? So let me just write down instead of having more symbols, minus 4ac by 4a. Correct. So what is your a value? A means what? Is it minus b by 2a?
No,
It's this part, right? It's this part. Huh? Because this is the y value. We are interested in the y value, not the x value. Okay. This is correct actually. Your formula is right. If I want to write the shortcut, minus delta by 4a to infinity. But you should know, right? How does this come from? So any logic for this? So you just by-hearted this. Okay, let's say we don't know this vertex. So how to figure out? What is this? This is nothing but x square minus 5x plus 6, correct? Can't you find the minimum value of this? What is given? Minus? How do you know that? I don't know the formula. So I don't know whether this is right or wrong. So if we don't know this formula, we don't know this vertex, right? This is a vertex of a parabola, right? Which is true. But if I don't know the vertex, can you just figure out using this algebra without graphs? What is the minimum value of this? That's what I want. What is the minimum value of this equation? Does anyone? No? Have you heard about completing the squares? Yes. It's a quadratic equation. Didn't you even try that? Can you complete the square here? How to do it? X minus 5. See, this whole square should cater to these two numbers, right? So x minus what whole square? X minus is 5 by 2, right? Why? Let's see. if I square this is x square. This is minus 2 into a into b. Can you see that this will get cancelled and you get minus 5x. Whatever the extra term is, this is plus 25 by 4. Correct. I can just subtract that outside. Is it fine? The only problem is these variables. Once this variable is fixed, the constant part you can add or subtract, doesn't matter. Right? So how do you write this? You simply take x if it's here. If it's x squared, you take x. You take half of this, right? With the sign. If it is plus 5x, you take 5 by 2. If it is minus 5x, you take minus 5 by 2. Okay. So what will happen? This will directly get x square.
It's not x. It's 2x.
Here 2x. Can you ask
2x square.
2x square? Can you complete some problem like 2x square plus say 3x plus 6, something like this? So I'll remove the 2 outside first. Now,
Sir, in a case where you can't,
give me an example where you can't.
2x square plus 5x plus 6.
Yeah, in this case also it was 3x, odd number, right? 5x plus x, 5x plus whatever, right? You can simply remove out the 2, right? Instead of writing 5, you'll write 5 by 2, that's all. Nobody said it should be a whole number. That's fine. Instead of 5 by 2, now what will happen inside? It will be x plus 5 by 4 whole square, that's all. Whatever number is there divided by 2. We never said it will be a whole number or it will be something divided by 2, right? So that's the idea. Why do we do this? Any idea? Why do we do this completing squares? What is the advantage we get? What is the advantage we get? See, we have this equation and we have this equation, correct? So what is the advantage we get by converting this equation to this equation? Okay, this is not complete though. There was a 6 outside, so I have to add 6 outside. Look at this equation. If you try to find the minimum value, right?
It would be negative.
It would be, you put negative values, right? It is going some positive value, right? If you put positive values, there's a minus sign, it's decreasing, so on. You're not able to figure out which value is minimum, right? If you simply plug in values here, you won't be able to figure out for what value of x this is minimum. But look at the other case. Let me just simplify this. X minus 5 by 2 whole square. This is what? Minus 1 by 4. After taking LCM. Okay. Look at this. What's the minimum value of this? 0. And this is always greater than or equal to 0. Correct. At x equal to 5 by 2, this is 0. Is it fine? So the minimum value is 0. What is the total minimum value? 0 minus 1 by 4. It is minus 1 by 4. Are you able to follow? Okay. That's why we complete the square. That's how you got this formula also. I don't know if you have seen the derivation or not. Okay. This derivation you get if you take ax square plus bx plus c equal to 0. Is that fine? You do the same thing. You take a common, x square plus b by ax plus c by a. Now you can simply cancel off a because we are assuming a is not equal to 0. Because if a is 0, it won't be a quadratic equation at all, right? So if it's not equal to 0, simply complete the square here. See, this is b by 2a whole square. Extra term is b square by 4a square. Plus b. So here you can see the minimum value is when this is 0, right? When this is 0, x is minus b by 2a. And this is the value of your y, which is, if you take the LCM, it is minus b square minus 4ac by 4. It's not required derivation right now, but If you are remembering the vertex, you should know why it's come, right? Fine. So any quadratic equation given, this is how you can figure out the minimum value, either by completing the square or drawing the graph. Okay, either by using this vertex formula, if you can remember. Otherwise, I think completing the square is always easier. You not remember anything. Fine. Little, if your quadratic equation is something like this, minus x square, say minus 5x minus 6, what will you do?
Minus and outside.
You take minus sign outside, but will you get a minimum value now? Will you get a minimum value? Yes, the graph will be upside down. This won't be a graph, your graph will be something like this. So you won't get minimum value, you'll get a maximum value. Minimum value is minus infinity. Here also see, maximum value is infinity. Here minimum value will be minus infinity to go to some a. A might be positive or negative, it doesn't matter. Right? Just giving a rough idea how a quadratic equation looks like. Okay. We need not worry too much about this. I think one or two problems are there in the sheet. That time we'll discuss. I just wanted, if you know something about quadratic equations, right? You can figure out the range. Is that okay? Let's see some other special functions. If you want, you can try this out. Those who are interested are fine with quadratic equation. We can try this at home. X square minus 5x plus 6, right? 1 by x square plus 1 and 1 by x square minus 1. You can try these three problems. See what you are getting, domain and range. And you can try a generic one. Why stop there? X square, say minus 3x plus 10 and 1 by x square minus 3x minus 10. Fine. Just for practice, you can try. Not so important, at least for 10 standard. You need to know the range and all. Sorry, you need to know how the quadratic equation behaves, but you need not figure out the range of 1 by a quadratic equation, right? Okay. Let's move on to some other functions. Have you seen this function e power x? Yes. Has everyone seen this function e power x? No? Okay. Let me remove e. Why to use e? 2 power x. Have you seen this function at least? Yes? Everybody have seen. Okay. So what's the domain? All real numbers. Okay, great. What is the range? All real numbers. Positive real numbers. Is it 0? What about 0?
No, it won't be zero.
It won't be 0. No. Sure.
It will be one.
Lowest is 1.
Yeah.
Then what about numbers between 0 and 1?
Except zero.
Not greater than 1. Greater than 0. Greater than 0. Sure. So some people are saying greater than 1. Okay. The range is 0 to infinity. We can't include 0. So we have 0 to. See, those who are thinking it's greater than 1, it is greater than 1 if I restrict my domain. What should be my domain? If I want this to be my range, let me ask you a different question. Yes. If I want my range to be 1 to infinity, what should be my domain?
It will be positive along with zero.
Positive integers. Is it clear? If I take 0 to infinity, see what will happen. At 0, this is 2 power 0, which is 1. Okay. Then you can take 1.1 also if you want. 2.1.1. This is little greater than 1. You may not able to figure out the exact value. You need a calculator there, right? But 2 power 2 at least you know, correct? It's 4. Next it will increase. It will go to 8, so on. It will go to infinity. But it will start from 1 when this is from 0 to infinity. Suppose you have a negative number. What will happen? See, minus infinity to 0. What will happen?
Zero. Yeah.
Huh? For 2 power x, it will be 0 to 1. Everybody agrees? Okay. 0 to 1. We can include 0? Yes. 1 can we include? 0 is included, yes. Sorry, we can't include 0 because at minus infinity this is 0, right? So, that's it. Is it fine? Again, you can take examples if you want. Take a negative number. For example, minus 1. What is 2 power minus 1? It's same as half, right?
Yeah.
Which is 0.5. Right? Any other number you take, 2 power minus 2, we're taking integers just to be, just so that we can do the calculation. That's all. I can take any fraction if you like, right? So minus 2, this means 1 by 2 square, that's all, which is 1 by 4 or 0.25. Right? Therefore, any number, any negative number you take, it's always a number between 0 and 1. Is it fine? Okay. So what about 3 power x? Huh? All real? Okay. What about range? Same. 0 to infinity. Okay. Let me not include. Now, what is this e power x? Yes, all reals. What is e? 2.71 something, right? It's called Euler's number, right? Any idea how do we get that number? 1 by 2 plus 1 by 3. Okay. There's a function actually e power x. It's 1 plus x by 1 factorial plus x square by 2 factorial. So it's not 1 by 2 plus 1 by 3. It's 1 by 2. Then it's 1 by 6. So now if I put x equal to 1, this is going up to infinity actually. Yeah, that is also the same thing, right? You can get the approximate value there. This is a generic function. What is e power x? Right? You need not know much about it here, but in 11th you will have it. Okay. So why is e so important? We use this in logarithms, right? Natural logarithms, what we have is using this e. Okay. Therefore, we calculate for e power x also. We'll see when we take up logarithms. Right now, this is just a constant, right? 2.7 something. Fine. So what is the domain and range? All reals. All reals. Okay. Ranges. Ranges. 0 to infinity. Doesn't make a difference. What constant value you are taking doesn't make a difference, right? So now suppose if I take half whole power x. Suppose I take half. All reals? Okay. What is the range? 0 to infinity. No difference between 2 power x and 1 by 2 power x. Is there? 0 to infinity? Sure. Okay. Actually, right. If you want to analyze this differently, look at this. This is same as 1 by 2 power x, correct? Fine. Just look at this example here. And this. Okay. When x is negative, isn't 2 power x similar to 1 by 2 power x? Right. Correct. And when x is positive, what happens? So this 2 power x will be similar to 1 by 2 power x for this number. Are you getting? When x is negative, it will convert to 1 by 2 power x, right? When x is negative for this this part, it is converting into numerator 2 power x, right? Just for example, if it's not clear, see when I take x equal to 2, this is 2 square, correct? This function is 1 by 2 square. Fine. But when I take x equal to minus 2, this is 2 power minus 2. What is that? Same as 1 by 2 square. But this denominator will be 1 by 2 power minus 2, which is same as 2 square. They are just interchange, right? Depending on whether the x is positive or negative. So there's no much difference between these two functions. Okay. Now I want you to do one thing. Draw the graph of 2 power x. 2 power x. I want to see how it looks like. Draw the graph of 2 power x. After that, you can draw the graph of 1 by 2 power x. Both I need. So 2 graphs. Yeah? Straight line? Just try and draw it. Let's see. Let's not guess. Let's take some values and try to draw the graph. How you draw any graph? What do you do? Plot the lines. But if it's not a line, plot the values, right? You just take some values. Take some values for x, right? Get the value of y. Just mark it on the graph. Rough sketch would be fine. I need not be so accurate. But I just want you to see how the graph looks like. Straight line. No. Plot some points and see. Try to join those points and see how it behaves. Take some sample values x equal to 1, 2, 3, 4. Even from negative values, take somewhat like tan. No, tan is totally different because tan repeats itself, right? After a while. That doesn't happen here. It's okay. You will not get the exact graph. Just try to plot it and see how it behaves. That's all. What do you think the graph should look like? Then we'll figure out. Yes. Kind of a parabola. It will look like for one side, but not exactly. Parabola should have both the sides, right? So, yeah. What about this curve? What happens to the other side? Try to plot what you can. If you have a doubt how it behaves, take more points and see. Right? Take some more points and try to join them. You will get a better idea. Will we try now? The people have some idea, right? Something you could get. So what are the sample values you do? Let me know. Let me write. X is 1. What is y? 2. Okay. Then x is 2. Y is 4. Okay. Okay. X is minus 1. Okay. 3 I'll write is 8. So minus 1 it is 0.5. 1 by 2. Okay. That's it.
Then minus 2 will be 0.25.
So 1 by 4. Yeah. 0.25. Right. Okay. I think you have missed 0. We can write 0 also, right? So it will be 1. Correct. So can you plot these points and see what happens? Right. So this is 0. At 0, it was 1. Correct. So suppose this is 1. Fine. So at x equal to 1, we are saying y is 2, double of this. Fine. At x equal to 2, this is somewhat here, 4. When it is 3, it's 8. Is it okay? So for negative 1, we are saying it's half of this. For negative 2, it's again half of this. So it will keep, yeah, it will never meet x-axis, right? The distance will keep on reducing, but it will never meet x-axis. So your graph will look something like this. Fine. It's fine. On the other side, it will go something like this. Let me just. So this is actually a graph. That's it. So it need not be a specific shape, right? We are drawing a new graph. Whatever we join the points and get will be a new graph. Okay. So your graph looks something like this. Okay. What about this 1 by 2 power x? Anybody?
The opposite side.
Opposite side?
Yeah.
Okay.
Here.
So the same logic will be applied when x is positive. Now it will come this side. If you want, you can check. At 1, this is half, right? At 2, this is 1 by 4, half of that. Half of that, it will keep on reducing. Now, what when it's negative, for example, x equal to -1. So at -1, this is 1 by 2 power -1, which is 2. So you can see the next value is here, 2. Then it will be 4. Then it will be 8. So it will increase something like this. Is it fine? So this is a graph of 2 power x. This is the graph of, say, 1 by 2 power x. In general, you'll have graph something like this, right? So 1 will be a power x, 1 will be 1 by a power x. Right? If you draw it smoothly, probably you'll get something. Right. So these are called exponential functions. Right. Why we are writing the variable in the exponent there. You can see a is a constant. Doesn't matter. Even if it's e power x, it will be something like this. 1 by e power x. E is just a constant right now. It's 2.7, right? So it doesn't matter. 3 power x, 4 power x. Only difference is it will be much more steeper, right? It will go to infinity much more quicker. That's all, right? But the shape would be almost similar. You can see. If you're using GeoGebra, you can see all these graphs if you're interested. Okay. Yes. Next. Have you heard about LANX, logarithms? No? You don't, at least you know the domain and range? No? Okay. I won't explain in detail right now. I'll just tell you what is the domain and range. Fine. But when we do the chapter logarithms, probably we can see. So the domain is from 0 to infinity. Right. So this is very basic. This x, what is there, can never be negative or 0. Log of a negative number is not defined. Fine. The log of always a positive number is what we take. Okay. But the range is from minus infinity to infinity. Or R. Fine. So for logarithms, there are two types of logarithms. One is written as log x like this. One is written as ln x like this. I'll tell you the difference. Okay. Both the domain will be the same and range is also the same. Okay. In logarithms, there's something called base. So we say log x to the base a. Okay. Here, whenever we write ln x, it is usually to the base e. Therefore, we use a different symbol called ln. Whenever it's base e, we use ln. It's called natural logarithms. Okay. There's something called common logarithms where we use base 10. Okay, this is called common logarithms, right? Otherwise, we can take any base we like. So in general, when you want to use different bases, we use log. Right? We say log x to the base 3 or log x to the base 10, log x to the base 20, so on. Fine. But now what we need to know is whatever argument is here, it doesn't matter what the base is, the argument should be positive. Okay. And the range is, it will take all the numbers from minus infinity to infinity. Is that okay? There are conditions on the basis also. So again, if you're supposed to find something related to a, or there's a variable in the base. Okay. The condition for the base is a cannot be equal to 1. Okay. And a should be again greater than 0. Why am I telling this? If suppose there's a variable in the base also, there are conditions on the base. For example, suppose they're saying it's log 4 base x. What is the domain now? 0 to 1? 0 to infinity, except 1,
Except one.
right? So you have to write 0 to infinity except 1. Okay. More in detail, we'll learn when we are taking up the chapter logarithms. Just to mention the domain and range, I'll just tell you. So condition on basis, it cannot be equal to 1. And for the argument, it should be always positive. Right? For example, if I tell you that find the domain of log of x minus 1, what is the domain? Log of x minus 1, what is the domain? One to infinity except 2. One to infinity. 1 included? No. Is it clear? How to get 1 to infinity? How to get 1 to infinity? It can't be negative, right? So you simply write x minus 1 should be greater than 0. This is the condition. So that means what? X is greater than 1. Therefore, I wrote my domain. Is it fine? What is the range? Can you tell me? Still all real numbers. Because still all the numbers you are taking care of, right? We are taking the numbers from 0 to infinity anyways. We're taking care of all the numbers. So the range will remain the same. What about in this case, log of mod x? Log of mod x? All reals. All reals. Sure. No. Except 0. Can't leave one number, right? It's not defined at 0. For negative numbers, it's fine. It will mod x will convert it into a positive number, but except 0. What is the range? All reals. No issues. Okay, let's see if I've understood quadratic equation. X square minus 1. Yes. 1 to infinity is the domain. Except 1. The 1 is not included. Are you sure? No. Think again.
Minus 1.
Yes. So it's minus infinity to minus 1, union 1 to infinity. What about the negative numbers? For example, minus 2. If you take minus 2 square is 4, right? It's positive. The logic is correct. You wanted x square to be greater than 1, correct? So you're saying that x square, if it is greater than 1, your condition is satisfied. But that can happen in the negative side also. It need not be positive, right? If the number is less than minus 1, still this happens. Okay, is it clear? What about the range? All real. Let's see. Okay, you don't know much more about logarithms, so we can't have any other examples. Let's move on. Let's see other examples. Sine of mod x. Domain and range. This domain. Okay. Real numbers minus all reals. Well, see, when talking about domain, we are trying to figure out where it's not defined, right? If it is a numerator, I don't see an issue at all, right? Usually, unless there is a square root or something, or log or something, some special function, sine can take anything. It's defined everywhere. So all reals. What about the range? 0 to 1. How many say 0 to 1? Okay. Any other answer? Yeah, -1 to 1 is correct. Just because I put mod somewhere doesn't mean that the value will be positive, right? Sine of say 3 pi by 2, what is it? Sine of 3 pi by 2, -1. Let's see the graph. Okay. I don't know. You may not know directly. So, what about this part here? Is it becoming negative? Is it becoming for some positive x? This is what? This is pi. This is 2 pi, correct? Pi and 2 pi is already positive. Even if I put mod or not, doesn't matter. Right? If you require the number to be negative to get sign negative, that time -1 to 0 will go. Now, see, I'm talking about only positive numbers. Still, it's going negative, right? So it should be there in your range. Is it fine? Is it clear? Okay. Fine. What about mod of sin x? All reals. Range?
0 to 1.
Now it's 0 to. Okay. Now you can see that this part won't be there. It will be above itself. Okay. So your graph will look something like this. Okay. Because the negative value, even if I get say -half, it will be converted into half. That's the property of mod x. Okay. Fine. So can you draw the graph of mod x now? Graph. Sure. Okay. If you got this, then draw the graph of mod of x -1. If you got that, huh? Okay. Mod of 2x.
Steeper.
Steeper? Compressed. Or it's wider, right? Which one? Can you draw and see? Can you draw that? Steeper. X by 2? Wider. Why is that? I'm multiplying by 2, right?
Yeah.
So why is it steeper? It should be wider, right?
No, the Y will be greater for.
Oh, the y will increase faster.
Yeah.
Therefore, it will be steeper. Yes. Everybody else know the graph of mod x? Is it known? No? Can you draw? Can you try? Draw the graph of mod x, y equal to mod x. For others. Yes? Mod x. You same. See, any graph is given. Don't till now what happened is in high school probably you already knew the graph, right? Then you are drawing the graph. That's not how graphs are drawn. Okay. Now the function is given. Okay. You put in some values. You get what is the value of y. Just try to plot it. It might be wrong. It's fine. Once you draw it, you'll understand. Next time you'll remember. Yeah. Yes, it's x by 2. Mod of x by 2. Did you get the graphs? Yes? Okay. Let's try. Y equal to mod x. Some examples? Or what are the points you want to plot?
1, 2, 3.
1, 2, 3. Y is again 1, 2, 3, correct? Okay, then -2, 1, -2, -3. Y is 1, 2, 3. Just like at 0, we'll always take 0. At 0, it's 0, right? So 0 is 1 point. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. Fine. When x is -1, y is 1. When x is -2, y is 2. So you can see that we are going to get a straight line here and this side. something like this. Fine. What about mod of x minus 1? Same graph is shifted, right? 1 units to the right. Because it will be 0 at when x is 1. Rest is same. Okay. So your graph should look something like this. Fine. This is for mod of x minus 1. This is mod x. Next, mod of 2x. Yeah. Steeper. So when x is 1, I'll write the value here itself. Y is 2. Right. When x is 2, y is 4. You can see that this will increase. Right. When it is 1, I'm getting the value of 2. So it's somewhat steeper like this. Fine. So similarly on the other side, you'll get steeper. So this is what a mod of 2x. So just because we have multiplied by 2, don't assume that the graph will be wider. Fine. What about x by 2? Yeah, now it will be wider. It will. Yeah. I think I should have drawn with different colors so that it will be clear. So this will be. It will look something like this. You can try this out. So this is for mod of x by 2. Fine. And let me see. This was mod of 2x. Have you seen this function before? Yes. What is it called? Slope? Floor. Floor, it's a part of this, but not exactly this. This is called, just make a note of this. Okay, this is a new function which you are learning. It's called greatest integer function. What is it? Greatest integer function. So from the name, can you guess what is it? Nearest integer. Nearest greatest integer. Okay, let's try. 2.2. 3. 3 or 2 now? 2. Okay, we are just guessing right now. Anyways, yeah, this is actually equal to 2. Yes. So the definition is the greatest integer less than that number. Is it clear? Whatever x is given, the greatest integer less than x, you can have equal to also if you require. Yeah. That would be an issue, right? If I am talking about the greatest integer, if it's greater, it can go up to infinity. 3, 4, 3 is smaller than 4, so it will go. But if you say less than x, there's a certain number always. Just next to that, one below, right? Okay. So this is not written properly, so I'll write less than equal to x. So integer part of that is always less than equal to x. Fine. Is it clear? So what about say 3.1? 3. What about 0.5? 0. Okay. What about minus 1.5? Minus 2. Why is it not minus 1? Minus 1 is greater. Okay. So be careful when you're writing negative numbers. This is called integer part of that. So we want the integer to be less than that number. Fine. So what about integer part of pi? 3. Clear. What about integer part of minus pi? Minus 4. Now is it clear? The function is simple, correct? Very, very simple. You have understood for any number I give, you can find out the integer part. Yes. Now draw the graph of integer part. Try to draw the graph of the integer. Or maybe you can draw that. It will not be continuous. Yeah, understood what the integer part is, right? Now take in sample values and try to figure out. Yeah, just draw that. Just see how exactly you're getting that. We have not discussed about this. What is the integer part of 3? 3 or 2? 3 itself, because we said less than equal to. Okay, so if it is an integer, it's itself. Right. Take in some more points if you are not able to figure out how the graph looks like. They get the graphs. Yes? Yeah? They form? Step. Yeah. You get something like steps, right? Let's see. Okay. So what are the values you have taken? So at 0, is it 0?
Yeah,
Right? What about 0.1?
0.
0. 0.5? 0. Till where it is 0?
0.999.
0.9999, still it's 0.
Yeah.
Right? Then it changes at
1.
1. So can I draw that in the graph? So if x is 1, up to 1 it is this part, correct? Fine. At 1 it is somewhere here. Is it okay? What about 1.1? 1. 1.5 also is 1. Up to 999 it is 1. Then it becomes 2. So you get the logic, right? So it will go up to 2. Yes. But it's not equal to 2 at 2. At 2 it is 2. You have to put like this. You put X mark where the point belongs. Right. For example, you can see there at 2, it's not actually 2. But very close to 2, it's still 2, right? But at 2, it is actually here. Similarly, at 1, it's not this point, it's the above point. So it will be something like this. Your graph will look something like this. On the negative side again, at -1, see, minus 0.1, it's -1, correct? So up to minus 0.99, it's -1. Then it will come -1. And just below -1, it will go to -2. So just below -1, it will go to -2. So the graph will look something like this. Is it fine?
Can we not connect the X and
That connection, okay. This point, like this. At 1, it is taking only one specific point. See, when do you get this line as a graph? Suppose this is say -10. -10. If y is equal to -10, that means whatever values of x, I'm always getting -10, then you get that line. You see, for any value of x, I'm getting -10. That's how the graph will look like. But here, what are you getting? For 1, it's one specific point. Therefore, you will get only this point. That's why I marked only one point. Is it clear? Okay. Is the graph clear? Are you able to figure out? Okay. So those who are interested can try this at home. You know what is sin x, right? Try to draw the graph of mod sin x. Sorry, integer part of sin x. And try integer part of cos x. Then if you could draw this, you can try integer part of x square also. These are not simple, you can just try them. You see what you are getting. We'll figure out, then we'll see in the next class. Is it okay? Okay. Now we have understood the graph, how it looks like, and what the function is. Can you tell me what is this? What is the solution for this equation?
Two to 2.999.
2 to 2.99. Any better way to write it?
Yeah.
So your solution is x belonging to 2 to 3. Right? Now we know how to write in brackets, right? So easier to write. So you can see that solution of this is this. Is it clear? What about is equal to minus 4? Huh? Minus 3 to minus 4? Minus 4 to minus 3. Yeah, fine. Minus 4 to minus 3? Yeah, smaller number to greater number. Okay. Okay. What about integer part equal to 5? It's not possible. No solution. Whenever you get, this means belongs to null set. Okay. So the integer part will be an integer. Anything you take, it should be an integer always. Is it fine? Is this part clear? Okay. Then for domain and range, what is your domain of integer part?
All real.
All real numbers. Okay, fine. What is the range? All real numbers?
All integers.
All integers. You're gonna get your output only as integers, right? So it can't be all real numbers. Is it clear? The domain and range. Okay. Then answer this. 1 divided by integer. 1 divided by integer.
All real except 0.
All real numbers except 0?
Except 0 to 1.
Except 0 to 1, correct. Except 0 included, 1 excluded. Because that's the region where it's 0.
Yeah.
Okay. What is the range? Integers?
All reals.
All reals?
And negative.
0 to 1?
0 to
Rational numbers. Okay, what is rational numbers now? In P by Q form. Is 2 a rational number? Yes. Okay, root 2? No. So all rational numbers is possible? So can you tell me when is this equal to 2 by 3? Not possible. So all rational numbers is not the answer. Then all integers. No, integers in the denominator. Zero to 1. It's not taking all the values between 0 to 1. That's the problem. So you have to write your range as 1 by integer. That's all. 1 by n. Okay. Where n belongs to integers minus 0. You can write 0 to 1 only when it's continuous. If it's taking particular points. So what are the range? Range is 1, then 1 by 2, then 1 by 3. Between 1 and 1 by 2, it won't take any other value. Is it clear? Similarly, you'll get the negative side. So easiest way to write is in this form. Okay, you need not always get intervals. can get something specific like this. Okay. Let's see. What about domain? Integer part of sin x. -1, 0, and 1. That is the range. Right.
All reals.
This is all reals, and range is, as we said, -1, 0, and 1. Only 3 elements. Right? Is it fine? Okay. What about integer part of tan x? All real numbers?
Except odd integers, odd multiples of 90.
Odd multiples of 90 degree. Okay. Or pi by 2. Fine. And belonging to integers. What is the range? All the integers. Because it's going from -infinity to infinity, right? And the integer part of that will take care of all the integers. Is it clear how different questions can be formed here? Okay. So let's see. Integer part of x square.
All reals.
All reals. Okay. Domain is easy. All reals. What about the range?
All positive integers. Or whole numbers.
Or whole numbers. Not all. What are the specific numbers? Perfect squares. Positive integers or perfect squares?
Positive integers.
All integers.
All positive.
All positive. Those are saying all positive integers.
All whole numbers.
All whole numbers. Okay, fine. Positive integers, whole numbers. But some people have a doubt about perfect squares, right? No? Clear? Okay. So if you are thinking about x equal to 1, then it will be becoming 4. Yeah. But you're taking only the values 1 and 2. There are values in between 1 and 2. Right? So if it reaches √2, it will change in integer. What's your problem? Come here. Come here. Next time will be out of my class. Okay. Yeah. So then integer changes at values like √2 and √3. Is it fine? So that's the reason it is all integers. Oh, sorry, positive integers. Is it clear? So what will happen is, see, 1 to √2, this will remain 1. √2 to √3, it will turn into 2. Are you able to follow here? Yeah. Then √3 to 2, actually it will turn into 3. Then at 2 to next number, it will turn into 4. Okay. The only difference is instead of x, we have x square now. So it's little bit difficult. Doesn't mean that it's jumping from 1 to 4, right? Obviously, if you put x equal to 1, next number you put x equal to 2, then it will jump from 1 to 4. But if you check the numbers in between, like 1.1, 1.2, so on, you'll understand that it will take all the integers. Okay. Even 0. So I think you can write r plus 0. Is it okay? You couldn't understand. Okay. What according to you is the range? No. Do you agree with the range? How do you get the number 2 then? Can you tell me? Where do you get the number 2? Like when is this equal to number 2? 1 square is 1. 1.1 is also 1.21. Okay, let's see. 2.1 square is what? It is something greater than 4, right? So when is this equal to 2 is what I'm asking. 1.4. You agree 1.4? Okay. 1.4 till where? Can you give me an approximate value? 1.9. What is 19 square? 361. The 361 means it's 3.61. What is the integer part of 3.61? 3. So 1.9 doesn't work. What else? 1.6. What is 16 square? 256. Okay, 1.6 works. What about 1.7? Will it work? Huh? Works. Okay, 1.7 also works. What about 1.3? Does it work? No. Can you tell me where exactly it will change? So you're saying 1.3 doesn't work. 1.4 works. Aren't there numbers between 1.3 and 1.4? Yes. So which number exactly will it change? 1.39. It's very close to 1.4, right? 14 square is how much? 196 is actually 1. It's little greater than 1.4. That number is root 2. Yeah. How do I know it's root 2? Root 2 square is what? 2, right? So that is a number where it changes, correct? You get the idea. See, it's root 2. I chose this number because this is a number where it becomes an integer. I didn't even find out what the values are. Okay, root 2 square is a number where it changes. Little less than root 2, it is less than 2. The square is less than 2. So the integer part will be 1. Little greater than root 2, the integer part will be 2. So that's how I figured out. Right? That's why these are important points. If you try to draw the graph of this, as I mentioned here, right, you'll understand all these points. I don't know where I've written it down. Okay, I told you to draw the graph of sine integer part of this one and this one, right? Try to draw the graph here. So while drawing the graph, you'll understand. Again, you will get steps, different kind of steps. You'll understand where it changes. Okay. Okay. So is it clear? Yeah. Integer part of x cubed then. All positive integer. That's what I wrote, right? Oh, sorry. This is not z plus, including 0, right? Or you can write whole numbers, but we usually don't use those symbols, right? We use integers, we use real numbers. That's a symbol. We use rational numbers as q, but we don't go to natural numbers. And natural numbers sometimes we use it. There's nothing specific about it, but we can write it in a standard format. It's better. Okay. What about integer part of x cube? All real. Okay. This is very easy. Right. Domain is right. All integers? Even in between? Sure. Positive integers? Yeah, it's x cube. It can take negative values. All integers. Okay. What about this? Now I'll have integer part whole square. What about this? Integer part whole square. Okay. Domain is all real numbers. Range.
Now it is perfect square.
Now it's perfect square.
Yeah.
Sure. Okay. Because the range of this we have already seen, right? It's where is it? Is it range of this? It's set of integers. Now squaring those integers. Now you'll get only perfect squares. Okay. If it's inside, it's a different solution. Okay. If it's outside, it's different. Okay. So you can write as perfect square itself. There's no particular symbol. You can write examples and you can note it down. Okay. Have we taken 1 by? Yes. Okay. 2x. Yes. Yeah. It would be fine if you like. If it's a subjective answer, you have to give your justification. Right. For this, see, perfect square, there's no particular symbol and all, so it's always justified. Right? Huh? Yeah, domain is real numbers. What about the range? Even integers? Even integers? Yeah, multiples of 2. Okay, so this can never be equal to 1. Yes. Yeah. What is the example for 1? Yeah, 0.5, it's 1, right? 0.6 also it's 1. 0.7 it's 1. When it becomes 1, it becomes 2. But between 0.5 and 1, it remains 1. It takes all the integers. See, just because I multiply 2 inside, so don't just assume that it will happen. The values will change. See, between 0 and 1, before it used to be 1. Now between 0 and 0.5, it will be 1. Clear? Okay. So if I have x by 2, same? Both are same? Yes. Again, the values where the integers change will be different. These are similar, this, and this. Only difference is the number at which it changes to 2 to 3 is different. Okay, but it takes all the values. Okay, is integer part clear? Huh? Then can you solve this equation? X plus 10 equals 12. What is the solution set for x? Yes? Yes? 2 to 3?
Yes.
3 not included. Yeah. This directly without solving you can guess, right? Yeah. What about x minus 1? 3x minus 1 is equal to 4. Now, zero to minus 1, sure. I'll just check an example. Minus 5, minus 0.5 fails. Wrong. Minus 1 to, yeah, minus 2 to minus 1 will work, right? Minus 1 included? Actually, it's included. Minus 2 is not included. Yeah, minus 2 is not included. Again, minus 1.5 you take? Yes. Minus 2. Yeah, at minus 2 it will be 5, correct? So I am excluded minus 2. But if it's just greater than minus 2, like minus 1.99, 3 minus of minus 1.99 will be 4.99, will be still 4. Right, clear? So this you have to calculate. Okay, what about 2.5 minus 2x equal to 10? Minus? No, certainly not. It will 9 to 10, it will be negative, no? Minus 4 to minus, let's see, minus 4 to minus 3, including both, or what is the point? Not including minus 4. Okay. So minus 3, it is 6. No, it's not working. No. Even minus 4. Okay, minus 4, it's working, but not exactly right. Huh? Minus 3.25. Minus 3.25. Okay, minus 3.25 to minus 4.25. Let's see. Very specific number. Including any side? Including any number? Including minus 3.25?
Yes.
Okay, let's see. Let us check a number in between first. Minus 4. What happens at minus 4? This will be 8 plus 2.5 works. Okay, between number that is minus 4 works. What about minus 3.25? Let's check. Minus 3.25. So into 2, 7.5 plus 2, 2.5, it's 10. Okay. What about minus 4.25? Doesn't work. Yeah, this will be what? Into 2, 8.5. 8.5 plus 2.5, it will be 11. This is what we want, right? Number should be between 10 and 11. So how did you find this number? You simply substituted values. Yes. Yeah. Yes. 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 So what he did is he just equated to 10 and 11, but indirectly what he's done is he just took this equation, right? Said this should be greater than or equal to 10, correct? This is what he wants. And this should be less than 11. This is a condition, right? When we say integer part is equal to 10 means what? That's why I gave you some examples. Here, what you did is you directly looked at the problem and you guessed it. Correct? Here again, you could guess it, but it took some time. Now, here is a not that so complicated, but still a complicated equation. Correct? Now you need to use the logic. So when is this exactly 10? This is 10 when whatever is inside is a number between 10 and 11. That is the definition. Right? In general, I can say that integer part is always less than or equal to x. Correct? And greater than x minus 1. Is this fine? Right? It will always be true. Okay. So any equation given, I think this is logic. There are more applications for it. I think we can see next time. You can try to draw the graphs of those. And I think the majority of the problems in your problem sheet also you can solve. All right. So you can try those things. I think I'll discuss in the next class the problem sheet. There's some more special function which you have to take care. Then we'll go to the problem. Fine. I think you can stop here for today. Any particular doubts here? It's not clear. You can discuss. Yes. Which one? Which one? Integer. This one? Up. Got it. Okay. Any other specific doubts here? 2 root 3. This one. You're not clear with that. Okay. So did you understand this? At 1.4, what will happen? What is 1.4 square? 14 square, 196, right? So 1.4 square is 1.96. What is 1.5 square? This is 1.96. This is 2.25. Right? So what is the integer part of this? 1. What is the integer part of this? 2. But when does it change from 1 to 2? Huh? No. No. This is your x. So your x is 1.4 or 1.5. In between 1.4 and 1.5, it's changing. But where is it changing? You get my query? See, x is moving from 1 to 2. Okay. At 1.4, a particular point I checked, it was 1.96. There, the integer part was 1. At 1.5, I checked, it is 2.25. Here, the integer part is 1. Here, the integer part is 2. So, somewhere in between, it changed from 1 to 2. Which is that particular number? That's the number root 2. What happens at root 2? The square of root 2 is 2. Little below root 2, the integer part is 1. Okay. Little greater than root 2, the integer part will be 2. Similarly, in the next jump will be root 3. The next jump will be root 4. So on. Try to draw the graph of this. It might be more clear.